Hey everyone, and welcome. Today, we're diving into the fascinating world of isomerism in chemistry. Isomers might sound complicated, but they're actually pretty cool once you get the hang of them. In this 10-minute tutorial video, we'll break down what isomers are and explore the different types. But before that, let us define what isomers really are. Did you know, class, that isomers comes from the Greek word isos and meros, which mean equal parts? And yes, you heard it right. This term was coined by the Swedish chemist Jacob Berzelius in the year 1830. In general term, isomers are hydrocarbons having the same molecular formula but differ in structural formula, meaning they contain the same types and number of atoms, but the way those atoms are connected and arranged in some space is different. To elucidate this one, let me present to you some examples showing isomerism. So class, what did you observe about the given examples? Yes, very good. As you can see, they have the same molecular formula but differ in structural formula. Let's check these examples. First, we have the N-pentane. From the prefix pent means there's a presence of 5 carbon. Let's count. 1, 2, 3, 4, and 5. And the suffix ane from the alkane group that indicates the presence of single bond. As you can see, class, they are all single bond. Another example, we have the 2-methylbutane or the isopentane. The 2 here means in the second carbon, there's a side chain, which is the methyl with the chemical formula of the CH3. In our previous knowledge, we'll learn about the parent chain and the side chain. Parent chain refers to the longest continuous chain of carbon atoms, while the side chain is a smaller chain of atoms branching off from the parent chain. 2-methylbutane or isopentane is an example of having a side chain. The 2,2-dimethylpropane or the neopentane is a simple alkane with 5 carbon atoms where 2 methyl groups are attached to the central atom, resulting a highly symmetrical and compact structure. These are just examples of chain isomerism, or also known as skeletal isomerism. To avoid confusion, class, we should always familiarize ourselves with the uses of prefixes and suffixes in naming compounds. Again, we use the prefix iso, indicating a single methyl group branching off the second carbon of a chain, while the neo indicates 2 methyl groups branching off the second to last carbon of a chain, creating a more heavily branched structure. Another type of isomerism is the geometric isomerism. It is popularly known as trans and cis isomerism. Cis and trans are Latin words that mean on this side and on the other side. The isomers in which 2 similar atoms or group of atoms lie in the same side of a double bond are stated as cis isomers, whereas the isomers in which 2 similar atoms or groups on opposite sides are stated as trans isomers. So these are the examples of cis and trans isomer or the geometric isomerism. Now, let's explore the differences between cis and trans isomers in more detail. 2-pentene, which is a pentene isomer whose double bond is the second carbon. The functional groups are methyl and ethyl are on the same side. Similarly with hydrogen atoms, they are on the same side, which make it cis-2-pentane a crowded molecule. We have the trans-2-pentene. Trans-2-pentene is an isomer of pentene. In this molecule, two hydrogen atoms are connected to opposite sides. Therefore, it can be named as trans. And now, let's dive in functional group isomers. These are a group of isomers that have the same chemical formula but different functional groups. For example, the propanal and the propanon can be functional group of isomers. They are both compounds with the molecular formula of C3H6O, but they belong to different functional groups. So class, this is the structural formula of the propanal and the propanon. Propanal is an aldehyde. When we say aldehyde, it is a class of organic compounds in which a carbon atom shares a double bond with an oxygen atom and a single bond with a hydrogen atom. While propanon is a ketone. Ketone is class of organic compounds characterized by the presence of a carbonyl group in which the carbon atom is covalently bonded to an oxygen atom, meaning the carbon atom shares electrons with oxygen atom, forming a chemical bond, where both atoms contribute electrons to create a shared pair, allowing them to achieve stability in their outer electron shell. So we've explored the fascinating world of isomerism. We've seen how molecules with the same molecular formula can have vastly different structures and properties. From chain isomerism, where the carbon skeleton changes, to cis-trans isomers, where the arrangement around a double bond matters, to functional group isomers, where entirely different functional groups are present. We've uncovered the intricacies of isomerism. Understanding isomers is essential for predicting and manipulating chemical reactions, as well as for comprehending the diverse properties of molecules in various fields. Keep exploring the world of isomers. And remember, it's all about the arrangement of atoms.